The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to today's Tech Talk on data analytics and energy management in HVAC. My name is Sherry Adams, and I'll be the moderator for today's session. Please note that throughout the Tech Talk, all phone lines will be muted. This will minimize any background noise or feedback that could distract from the presentation. When you first joined the Tech Talk, an attendee control panel appeared on the right side of your desktop. On the left side of this control panel is a small tab with an arrow icon at the top. Pressing this icon allows you to minimize and maximize the control panel. When maximized, you can use the control panel to submit questions. We'll be gathering your questions throughout the Tech Talk, and we'll leave a little time at the end for Q&A. A PDF of the slides from this presentation will be sent electronically to all those who've registered, and we will also be recording this Tech Talk, and it will be available on our website under the resource section. The password to access the Tech Talks will be emailed out to all the members after the presentation. Today's presenter is Miles Smith. Miles is currently employed by CBRE Erie as the Senior Construction Project Manager and is embedded as the Senior Energy Project Manager at Northern Virginia Community College, the largest multi-campus community college in the U.S. He develops and implements HVAC controls, lighting, generator, thermal storage, metering, energy data analytics, demand response, and other energy and cost-saving projects and programs across 6 campuses, 50 buildings, and 2.1 MSF of floor space. Miles has 35 years of utility design, project management, energy management, lighting, retrofit, smart meter, and renewable energy experience. He holds degrees in management information systems and electronics and developed and taught the Army's Energy Manager Training Program. So Miles, welcome, and I'll hand this over to you.
Thank you, Sherry. Thank you for that wonderful introduction. So today we're going to talk about data analytics, and first we should probably define that. It's facts and statistics, but it's just data until it turns into information. So how do we turn data into information? What are we looking for? We're really looking for patterns and values in the data that's going to find problems, find potential cost savings. You should all remember that data is flowing at an increasing rate from an increasing variety of sources. There's a huge variety of software that you can use, from Excel to customized analytics software, which turns data into graphics. But I often get the question, well, what data package should I use? Which is the best data package? It doesn't really matter. Sometimes you have to use what you've got. I can remember 30 years ago using Lotus 123. I can remember using graph paper. I've literally used graph paper to graph out data and find anomalies, find problems, find patterns. It's patterns that you're looking for. So with the exception possibly of artificial intelligence, it's us, it's the human being that turns the graphics into theories, merge it with other knowledge that you've attained by conversations with other people, your eyes and ears. You're creating information from that and drawing conclusions. And I have to say, it doesn't matter how well a building or system is built and commissioned, there's always something wrong, always, if for no other reason than entropy. So why should the commissioning people care? Well, minimizing energy is very, very important to everyone. It's important to your customers. It's also getting harder to find energy savings and waste. So if you've lost the low-hanging fruit, or I should say if the low-hanging fruit has already been harvested, you need an alternative means to find those problems that I talked about a moment ago. So data analytics plus people that are good at looking at the graphics and finding it, actually have their heart in it, they're going to find those dollars that you can't find elsewhere. I'll give you an example. Low-hanging fruit, lighting retrofits. Let's say you have a building that was built 60s, 70s, T12 lighting, incandescent fixtures, that type of thing. It was improved in the 90s with T8. Then it was recently converted to LED lighting with occupancy sensors tied into the building automation system. Well, what you have is decreasing energy consumption on that building through energy conservation measures, the lighting retrofits, But unless something beyond LED comes along, how are you going to get any more energy savings out of it? Well, you can do that with analytics. You can squeeze out the last drop of savings by, let's say, going into the building automation system and reviewing occupancy sensors. Let's confirm that they're all working. Guarantee you some won't be. Some have been disconnected, some have failed, some have dead batteries if they're battery operated. Does the timing make sense? Maybe when they went in, they put them all at the default 30-minute delay. Maybe you can get away with 15 minutes. So analytics gives you the ability to go in and squeeze out that last little extra drop of savings. Don't forget that analytics market penetration is increasing. Most of your building automation systems already have it. If they don't now, they will soon. And really important for you guys, you got to find the oversights and errors. You can find it in the data, and if you don't, somebody else will. I know because I found errors such as that. So a couple of things to think about. No two buildings, patterns, rates, this stuff is all snowflake. No two are exactly alike. And you are the analyst. You need to think about what's going on. You need to have context. It really is, I use the term Sherlock Holmes because you don't know what you're looking for half the time. You need to go into a building or a system and look at the data that's coming out and say, does this make sense? Does what I'm seeing graphically represent what should be happening? Or is what I'm looking at, does it represent something that may be amiss? The other is don't just stare at the computer screen. A lot of people like to do data analysis from their chair, and you're never gonna get the whole picture by doing that. You have to walk the building, understand the systems and how the building is being used. Talk to the occupants and maintenance staff. Make sure their stories align. When is this building operated? How is this building operated? Augment your data with loggers. If you don't have data from a building automation system, you can always put in data loggers. Look at the utility invoices and make sure you understand how they're being invoiced. What is the demand cost? What is the cost per kilowatt hour? What is the cubic foot of gas cost? All of those costs, you really need to know them. And another is just park outside and see if what you're observing with your own eyes matches what you found out from the occupants and the maintenance staff. If you're going into a project and there will be not just you doing your commissioning, but maybe you have a lighting engineering company or someone else going in, establish in advance who gets credit for what. Because chances are, if you're doing data analytics and your sub is doing data analytics, you don't want to end up in an argument over who found what. I've seen that happen before. So by way of example, let me show you, this is at Alexandria campus at Nova. Some of these things are not obvious to see, but this one really is. This rate is the 6VA rate with the Commonwealth of Virginia, which was the rate used at the garage. And that rate has a 50 kW minimum demand. That's that yellow line that you see at the top. The blue line at the bottom that goes up and down and up and down, that's actual demand. So we were being billed for 50 kW, and what we're actually using in kW is the blue line. And you can see towards the left, the difference is about 10 kW. Well, as it turns out, 10 kW in the 6VA versus the alternative, which is the 5VA, it's about a wash. The big drop towards the middle is when I did a lighting retrofit, and we went from HID, I think it was sodium vapor, to LED. Big drop in demand. Now that delta between the minimum 50 kW and what we're actually using is very large. So in short, the resolution to this was go to the power company and say, I believe I'm seeing something in the data. I believe we can achieve savings by moving to a different rate. They are required by regulation to provide us with a comparison between the two rates. Lo and behold, I was correct. And it was a very simple change to go from the 6VA to the 5VA, about $3,000 a year in savings. Now ask yourself, when you recommission a building, do you look at the rate options? Do you ever even look at the rates? I think a lot of companies don't do that, and that's a great value-added service for your customers. Here's another one. Now this looks the same, but it's actually significantly different. This is a much larger building. This is the medical education campus. They had contracted when the building was built for a 1,000 kW minimum demand. And you can see the amount we used was way under that. Now this wasn't a matter of changing rates. This was a contractual issue. So again, I went to the power company and I said, please do an analysis and tell me why it's so high. They came back and what they told me was that the initial A&E firm that designed the building had given them a load letter. It's a very standard procedure. Here's what we, the A&E firm, believe you're going to use in this building. Well, those are almost always estimated high because nobody ever got fired for putting in too much capacity. Unfortunately, the power company takes it verbatim and they say, well, you told us it was going to be this load. We put in a 1,000 kVA transformer. Now you're telling us you want less demand, but we've already spent the money and put in that big transformer. And they try and intimidate you in some cases, and they did in this case, by saying, we're going to have to charge you a facilities charge. So it's probably not even worth you doing anything about this. Well, I used to work for the power company, so I said, oh, just tell me what the facilities charge is. This was a fantastic find, because after the facilities charge, we've now saved $31,600 a year forever. Now, we've been saving more money on this building over time because we've been putting in energy conservation measures over time. And so this number where I've multiplied it to a little over $500,000 is probably not that conservative, but figure 553, let's just call it $500,000 over 17.5 years. That's a huge savings that could have been realized if someone, maybe a commissioning agent, had reviewed the initial load letter when that building was built. Instead, we paid all this money for all these years. Now, we got another LED retrofit for this building that I just kicked off about 2 weeks ago. And what you're seeing in the yellow is where they dropped our minimum demand contractually. I'm going to ask them to go through this exercise again about a year after I do the LED retrofit, and I'll bet I can drop it even more. So I'm going to pay attention to this. Something else to look at here, which is not that clear to the naked eye, but you can see at the top, it is contractual and it's an absolutely horizontal line. Then it drops, and the line after that is not perfectly horizontal. It actually goes up a little and down a little. What they appear to have done is not change the contract value, but changed it to their standard ratchet. And the ratchet value after 12 months, if you have not exceeded your previous high, will actually drop down to the next high after that. Which means if this continues on, I may not even have to go back to them and ask them to drop it again. If it's following a standard ratchet, as we move down from the LED retrofit and use less demand, it's automatically going to track. Well, let's talk about building automation and analytics and building automation. There's a building at the Woodbridge campus. It's relatively new. It was built in 2013. And our director is very keen on making sure that we have our buildings scheduled for nighttime setbacks, weekend and holiday setbacks. Huge savings to be had if you're not running your building at full tilt all the time. And we have lots of opportunities for that. So between the director and the staff and me checking behind them and everybody working as a team, those schedules were perfect. We then brought in the controls contractor and they checked out everything and said, yes, indeed, Mr. Customer, Mr. Nova, it's tip top. Everything's just great. Then, more recently, late last fall, we had the analytics package installed and had electric meter installed in the switchgear. And all of a sudden, I could look at incremental data. I was very excited about this. So the package was finished with the install on a Friday. They had the weekend. I came to their offices in Chesapeake, Virginia on Monday, and I said, all right, well, let's see what we've got. I'm really interested in seeing what we have and how I can view this data. So here's a copy of the schedule, And if you look on the left, that big purple is Sunday, and a Sunday unoccupied all day long, unoccupied until Monday about 3 a.m. So that's what we wanted, and that's what everybody agreed. We've got those schedules in place. Fantastic. I said, show me different ways I can look at this data. And this is probably not the best way to represent it, but it's the way they showed it to me first. And I looked at that for a few moments, and I said, wait a minute, this is Sunday? They said, yes. I said, okay, it's Sunday. Why am I seeing high electrical demand at 3 a.m. on a Sunday morning? They said, oh, they must have overridden the system. And he pulled up another screen. Nope, they didn't override the system. All right. And I went from this screen. Unfortunately, I don't have screen captures for the other, but went through and said, show me output temperatures from the heat pumps versus room temperature and a few other things. And lo and behold, it appeared very much like the building wasn't being set back. They dug deeper and went into this is the actual coding for the building. And down here is the schedule. I blow it up here. So here's the schedule logic, and I don't expect anybody to understand this, frankly. I only understand about half of it, but I circled the important part, which they discovered. Now this is after they recommissioned the building controls. They said, oh my goodness, we found a TUNCOS variable set to 0. I'm like, all right, what's a TUNCOS? I have no idea. Time until next change of state. Well, time until next change of state was set to 0, which means that the system was always expecting that the state to change in 0 seconds, which means whatever the schedule was telling it to do, it was ignoring because it was about to change in 0 seconds. So they went in and changed the code. So was it successful? Intuitively, I absolutely know we're saving money because now schedules are being implemented as they are supposed to be, and they never were. The data, I have rough data right now, so it's relatively inconclusive. I'm going to revisit it this fall and spend a little bit more time on it, but I'm not too worried about it because I know darn well that it is saving money. And the frustrating thing here was for how long, for all of those years, we thought this building was being operated properly, and it wasn't. It was data analytics in about an hour's worth of effort that uncovered it. So what are we looking for in data analytics? We're looking for good patterns. This is a special forces building at a military installation, and it looks like there's some usage and then there's no usage. This is 6 of those days equals, or 6 of those time increments equals 1 day. So they're using some in the morning, the rest of the day they're not. I was told that the special forces, they were coming in the morning and doing their thing and going off and doing their training. So, okay, they came in, this is the winter months, and turned on the heat, this is gas, and then they went off and did their things. Well, that looks great. We're looking for changed patterns. Now, here's the difference between 2014 and 2015 in a nearby building. In 2014, we had obviously nighttime setbacks there. You can see the usage during the day, it goes down at night. I don't see any lack of usage in weekends, which tells me it's probably a 7-day-a-week operation. In 2015, that all stopped. The pattern went away. So that's something I'd want to look at. Now, it's possible that this is all correct. You never know. You never know without context. You have to talk to the building operators and the occupants and find out what's going on in this building. Does this make sense? Here's one that doesn't make any sense to me at all, so I'd want to look at that. It's all over the board. What are we looking for? This is a good one, is to look at the peak KW contribution. Your customers are going to be charged for the peak demand over some period of time. Usually it's the highest 30-minute demand in a month, but it varies by utility. So if you have multiple buildings, which this garrison did, a lot of buildings, which of these buildings is contributing the most to that peak demand? Maybe there's something you can do, like this was an industrial facility, maybe they can start running their operations at a different time to avoid adding that to the peak demand. And then you get really oddball things. Now this one's interesting. We have, it's a little bit hard to read on the left, but looks like you're using 2 kilowatt hours per hour, and then at night it drops off to 0. what the heck is this? I had no idea I've never seen a consumption pattern like this before. Well, it turned out that this was one of 2 photovoltaic panels that had been put on the roof of a building. It wasn't consumption, it was production. And it was being added into the meter data management system as consumption. It's so low, it really didn't have a net effect of much. But obviously, there's a difference between consumption and production. So this was a really oddball one. So the takeaways for today, you can get great information in the data. You can get information in the data through analysis that you're not going to get anywhere else. Make absolutely sure you spend enough time understanding the context of the data that you're looking at. Are the patterns that you're looking at, do they align with what's supposed to be happening in the building? Well, analytics can improve your effort, improve your efficiency, reduce consumption, give you possibly another value add for your customer, and it's just fantastic. There are so many different software packages out there these days that if you don't have somebody on your team or several people on your team looking at data, you're probably missing out on a lot. Now, let me go back 1 second to a slide that I showed you before. I told you that this was a good pattern and you probably took me at my word. Well, I told you it was a special forces building, which is true. However, what if it wasn't? What if you didn't know that? And what if this turned out to be an aircraft hangar with big banks of infrared heaters? Why would they be running all those heaters in the morning hours? Is there something that could be done to stop that from happening? Is it a control that was wrong? What if it's actually output from a boiler in August that serves no domestic hot water load, and that boiler is firing up every morning for no apparent reason? I think one of the coolest findings that I've made in a long time at Fort Carson, I had gone through and was looking for setbacks at a variety of buildings, and I found several that appeared to not be setting back, and I gave that information to the energy manager at Fort Carson. And Scott was a really smart guy, and he said, no, I'm pretty sure they're all being done, but I'll talk to my contractor. He came back to me, and not only were they not being done, but he told me about the one that he found that was the most interesting to him was a building that was actually doing setbacks perfectly. They were absolutely dead on perfect, but the building had been unoccupied for 2 years. Oops. So that concludes my formal presentation. I think we have some time for questions.
Thank you, Miles. Yes, if anybody has a question at this point, we don't have one, but let's give them a couple minutes to have the chance to ask a question. In the meantime, I just have a quick announcement, and that is to remind everyone that the BCA Annual Conference is September 25th, 26th, and 27th. In Schaumburg, Illinois, and the early bird registration does end on September 6th. So if you haven't registered, this is a great time to do it. And if you haven't already checked out the website for all the exciting things that will be happening at this year's conference, please do so. Let's see if we have anything at this time. Doesn't look like anything has come in at this moment, Miles, but sometimes I get a few questions that come in after the Tech Talk, and if that is okay, I could forward them to you after the presentation.
Excellent. Thank you for having me today.
Great. Well, thank you, Miles. We really appreciate all your time and your expertise today. And on behalf of the BCA, I'd like to thank everyone for your participation in today's Tech Talk, and have a great day.